So let's start off just by plugging in some points. And we don't have to go completely consecutive numbers, but get some negative and some positive, I suppose. I'm just going to go consecutive, though. That's fine. So yeah, plug those in. Each value, see what we get for f of x, and then we can plot. Remember, f of x is the same as y, the y-coordinate, y-axis. Plugging into negative x to the third minus 4x squared. And it's somewhat tedious, repetitive work, but it could tell us a lot of information. So what we got here? First of all, it's important to see what we got here. Let's see. Now this would be negative 125 minus 100. Is that right? Did I plug that in correctly?
Instead of a 5, it's supposed to be negative 5.
Oh, right here? Ah, there we go. A little mistake. Knew something was wrong. So 125 minus 100 gives us 25. And just repeat the process. So we have negative of negative 4 cubed and minus 4 squared. Okay. Simplify that. And this is where you can use the scratch paper you got out. Do the calculations on there or with your calculator and just fill in the number. So go all the way down. What do we get for negative 4?
0.
0. So that's a 0, huh? Okay. Negative 3. Negative 9. Negative 2. 8 or negative 8?
Negative 8.
Negative 8? Okay. Negative 1.
Negative 3.
Negative 3. 0. 0. 1.
Negative 5.
Negative 5. And 2. So verify you get those. One thing I'd like to throw out there. Okay. We know, let's see here, our polynomial is right here, and we know that there's no x or constant. So synthetically, negative 1, negative 4, 0, and 0. And if we plug in negative 4, we expect our answer to be what? 0, right? So if we go through and like as if we're looking for the roots, this is what we would find. Let's see here. Make sure we're doing it right. So negative 4, that'd be positive, that equals 0. And then we'll have what, 0 and 0. Yeah. So this means we have a root. Now, does that work for these other numbers as well? So let's say, let me plug in negative 5. Do I get, what happens when I plug in negative 5 into all this? So we have, what, negative 1, negative 4, 0, and a 0. Bring that down. We'll have 5, 1, negative 5, negative 5, and 25. Yeah, just as we suspect. So if right now you're plugging it in and you're doing, okay, negative 5 cubed minus 4 times negative 5 squared, you're doing all that, would you think that this is a little bit easier for plugging values in? If so, you can use synthetic division for all of this as opposed to plugging them one by one, if you like the synthetic division, because this number was always the remainder, and the idea that it's a 0 is what makes it a root, but the remainder turns out to be just the y value. And they call this the remainder theorem. Okay? But just know that you have an option. Now maybe it's not so bad here, but what if I told you, you had to do something like, this last one, this right here, by hand, no calculator. And then synthetic division would look really nice, because that's a lot of work to be cranking out by, it's cubed. Let's do negative 3 times 3 cubed plus 20 times 3 squared minus 36 times 3 plus 16. Synthetic division might be a lot faster in order to complete this table and get a more accurate graph. Also, if you find yourself getting a weird answer using one method, try synthetic division. Maybe you get the more accurate and correct answer using that. So you got multiple methods for doing the same thing. Alright, so let's go ahead and plot these. Did you plot them already? Let's go ahead and plot them. Negative 5, 20. Oh, first of all, you notice how nothing's marked here as far as 1, 2, 3, 4, 5, because we need to look at this and say, well, what should I count by? If I need to go from 25 to negative 24, what should I count by here on the y-axis? Should I count by ones? No, I can't count by ones. We only get up to 1, 2, 3, 4, 5, 6, 7, 8. We need to go to 25. So yeah, we left these blank. So for each of these, you'll have to first calculate and then decide what your scale should be. This is the scale. For the x's, as you can see, we can just count by ones here. That's not a problem. So we first have to solve, and then we can plot what we need. It is okay that they count by difference on the x and y. So the y's count by 5s. The way of noting that is you put a little triangle, say 5, and this one counts by 1s. So that triangle is actually a Greek letter, delta, which means the difference between one and the other is 5. The difference, delta d, is 1 between these. And then we can go ahead and plot all of it. So we got negative 5, 25. So that's like up here. We have negative 4, 0. So it jumps way down here. We have negative 3, negative 9. Okay, so I better mark this negative as well. Negative 5, negative 10. Okay. So we got negative 3, negative 9 right about here. We have negative 2, negative 8. Alright. Pretty close to that. 0, 0. Origin. 1, negative 5. Goes back down. And 2, negative 24. Alright, so using that outline, we can sketch the graph. Let's see, I'm going to follow my... Look, it turns right here. Goes close to 0, then turns back down. So on the left side, it's going all the way up. On the right side, it's going all the way down. Alright, what are my zeros here?
Negative 4, 0.
Yeah, we already figured that out. Negative 4 and 0. And how come there's only 2? This is a cube. We shouldn't have 3 roots, right? How come we only have 2 here? Okay. What would happen if you went through and solved this? and did the rational root theorem, synthetic division, got your roots, you'd find out this. Or if we just did this by factoring, if I take this and I factor it, I could take out a negative x squared, and I'm left with x minus 4. What's happening here is that we have two answers. Negative x squared equals 0. So if you square root both sides, you technically get a plus or minus 0. And then over here, when we do x minus 4, we get 0, so x equals 4. So we're actually getting 3 roots because we have a plus 0 and minus 0. It's just that that's the same number. Anytime this happens, visually, this is what you'll see. It'll bounce off, but it won't go through the x-axis. It's called a double root. Okay, it's called a double root. Mark that down so you have this on your homework. Okay, so even though it only goes through 0 one time, it counts as 2. It's like a plus or minus 0. And this is our third. So our third degree polynomial actually does have 3 roots. This was actually true with their parabolas, like this. This is like y equals x squared. Since it's x squared, it technically has 2 roots. On here, they just happen both to be 0. So that was called a double root. And you notice how it bounces off the x-axis and goes back up. It doesn't go through the x-axis, like here, like negative 4. So yeah, that counts as 2. That's 1. Relative max and min. So we're just looking at where it's high and where it's low. So like right about here, that's like a min. It's kind of going down. This is like a max. It's going up but coming back down. So there's a minor dips and hills in the graph. So when it's going down and then back up, that's a minimum. When it's going up and back down, that's a maximum. So we can say, the max is between, let's see here. Max is around 0. And the min we could say that's about negative 3. We could also say it's between negative 3 and negative 2. It's just an estimation because anytime we look at a graph and try to get exact answers, it usually doesn't go that well. So that's one problem. So we just have to repeat that process and look for changes. Another way to tell without graphing, how can I tell that there's a min or a max? You start looking at the signs. You can kind of imagine right here, okay, I'm at 25, I'm going down, hey wait, I went back up. I'm going down here and all of a sudden I go back up. So when you're going down and you go back up, that's like a min. And then okay, I'm going down, I'm going up, negative 8, negative 3, I went up some more, 0, I went up some more, negative 5, it went back down. So you can see where it changes. And we can even figure out these are mins and max without the graph, just by looking at the signs and see what direction's going. Alright, so let's try another. If you want, you can try the synthetic division approach on here. Maybe give that a shot if you want to use that other piece of paper. You can pick any numbers really. I'm just going to pick, let's see here. Well, I'll probably X that out for a reason, so I'm going to be safe. Just pick count by ones. So I can tell, since I'm counting by ones here on my x-axis, when I go to graph, I know I'm going to be counting by ones as well. So the changes on the table match the changes on the graph. Let's see here. I was doing this table synthetically, I'd do this. -1, and that's going to go into 1, -2, 0, and then 6. -1, -3, 3, 3, -3, and 3. So my guess is that you get 3 here. Is that correct? Good. And 0. Let's see. 0 is a little simpler to plug in. I just know it's going to be 0 minus 0 plus 6. Anything with a variable is now 0, so the only thing that's not 0 is whatever does not have a variable, which is 6. Plugging in 0 is usually mental math. Don't really need to write that out. If I plug in 1, -1, and -1, so I should get 5. Plug in 2. 2, 0, 0, 0, 0, 0. So 2 is a root, looks like, huh? So I put that down my 0 list. 2. Oh, the 6? Oh, 0 plus 6. Okay, never mind, take that back. Good call. Keep my stuff neat. So it's 6. Ah. I don't know why it does that. There we go. 6. Alright, keep it going. Let's see, we got 3. 1. Let's see here. 3. 1. 3. 3. 9. I got 15. Is that one good? Back on track. Okay. Four, 2, 8, 8, 16, 10. You got 38? You saying? What did I do wrong here?
It's 16 instead of 26.
Oh, that should be 32, huh? 4 times 8. 32. So shouldn't it be 32 minus 6? Which is 24? 8. 32. 32 minus 6. Is it plus 6?
Yeah,
Oh, I just was messy. Okay, that's 38. That's 38, okay. So either way, it looks like if you're not careful, if you're sloppy, you still have the same issues, huh? Alright. Okay, so what should our values be here? Or y, my x's. I mean y's and f of x's. What should I count by? Count by 6, and well, will this value down here really tell me anything more than I need? It seems like it's at 5, 6, it's getting bigger, 15 is getting bigger, 38 is getting bigger. So it seems like this value doesn't really tell me any information. It's not 0. It's not going to be by a min or a max. So we can exclude it and just count. Now, okay, I need to go up to 15. So yeah, maybe count by 3s. Now, sure, you could include it and then count by something bigger, but you can see how you can hear my thought process and say, well, I agree with that, or I know I want to have it on there. It's up to you. So graphs can look different, but still have the same information. And my x values, I'm still counting by 1s. So I'm going to go, -1, -2, -3, 1, 2, 3. That's as far as I'm going to go there. Negative 2, 10. Negative 1, 3. Negative 1, 3, where are you? Negative 1, 3, right there. And then 0, 6. And 1, 5. And 2, 6. And 3, 15. Going back up. Alright, and we can once again just read here and find the mins and the max. So I could see, okay, starting at negative 10. Okay, it goes up to 3, goes up to 6, it goes back down. So when it goes up and then comes back down, that's a max. So I know there's a max right around here. So it's going down, then it goes back up again. Then it goes back up. So I got a min right here. So I can tell just by looking at the numbers also, but I can confirm that with my graph over here.
Mr. Hodgins, let's see a negative 10 instead of positive.
Which one?
For negative 2, negative 10, put negative 2 in there.
Negative 2.
Negative 10.
Yeah, when you put negative 2.
Oh, no. No good, no good. Negative 10. Thanks. There we go. Yeah, so we still have a max here, still have a min here. And our 0, what does it look like our 0 is?
Negative 1.
Yeah, somewhere between. You can see here, see how I went from a negative to a positive? That means there's a 0 in between a negative and positive, right? So it's somewhere between there. I'm going to say between. Let's write that out. Between negative 1 and negative 2. So it's negative 1 point something, right? The max, I'm going to say, is at 0. The min, I'm going to say it's around 1. And again, I can get that from here. So a lot I can tell. I can tell, hey, there's a root right here. It went from negative to positive. There's a root between those two numbers. I can tell it's going, yeah, it starts small, gets bigger, oh, it starts going back down again. So that's a max. When it goes up and up and up and then starts coming down, that means it reached the top. And then also, it goes the other way as well. So it's at 6, goes to 5, gets smaller, hey, it went back up, so that means that's a min. It was getting smaller and then started going back up. So we can tell that's a min. Okay. And then this looks like it keeps on going up and up and up and up. Okay. So we're just combining a few things together, reading a table for our information, finding mins and maxes by looking at a table and by looking at a graph. And I showed you, well, you can either plug it in by cubing the number, subtracting 2 times the square plus 6, but I also showed you how the synthetic division gives you the y value as well. And as you saw, as long as you do your arithmetic correctly, you can still make mistakes on that. So whatever method you like, or do it one method and then check using another method to make sure it's super accurate. I think that's about it. Yeah, over here I actually gave you the x values to use because otherwise the numbers get way too big or way too small. But I would urge you to try on these ones, try the synthetic. So it's a quiz or a test, you forgot your calculator, what would you do? You'd probably use synthetic division, try to get those points. Okay. And if you can, maybe at the end, try to get the zeros the max and the min before you graph. So look at all the tables, see, I changed from a negative to a positive, or positive and negative. Zeros in between those two numbers. Okay, so it's one of the zeros between those two. The max, okay, it's going up and up. The numbers are getting bigger and bigger and bigger. Then they go down, so that's a max. Or the numbers are getting smaller, smaller, smaller. And then they start going back up, so that's the min. And then graph it and see if what you got from the table matches what you actually graph. As long as, of course, you're not like me and you graph it correctly. Okay, so be careful. Be careful. All right. Yeah, let you guys play with that. Finish this up tomorrow. We'll be doing a quiz on synthetic division, finding roots, finding zeros, graphing, all that good stuff tomorrow. Okay. Mins and maxes and